Can all of you see this problem too?
Yes.
Oh. So problem 2 is similar to the antennas question that you had in class. So let's start it. It says that we have a system which comprises of 5 components, which is either working or failed. Consider an experiment which consists of observing the status of each component and let the outcomes of the experiment be given by the vector x1, x2, x3, x4, x5, where xi is equal to 1 if the component I is working and is equal to 0 if the component I has failed. So technically 1 means it's working and 0 means it isn't working. How many outcomes are in the sample space of this experiment? So, any guesses? Two to the power 5 कैसे? ठीक है, तो technically exactly 2 for each component. So what we say is that you have one space, two possibilities, yeah. One space where you can either fit a 1 or a 0, either one of them. Then you have the second space, you can fit a 1 or a 0. So you don't know that these components, whether they're working or not working beforehand. You place it, and then after that you observe whether it's failing or not failing. So in that scenario, you have 5 antennas. You can place one antenna is either working or isn't working, and then you have 5 spaces that you can fill it into. So the answer, just like you mentioned, is 2 times 2 times 2 times 2 times 2, which is equal to 2 to the power 5. So yeah, just like you mentioned, a B part is placing a restriction on it. B part is saying that component 4 and 5, these two components, they both have failed. How many outcomes are contained in event A? So अब इनका हमें पता लग गया है कि ये they're not a 1, they're 0. So for only these two blocks, how many possible how many possible uh, arrangements can we have? So exactly, yeah, it's 1 because you only have a 0 and a 0 and they're both identical. So if you place 1 0 at one end and the other 0 at the other end, it doesn't really make any difference. The only thing that does make a difference is the first the first three components for which they can either be a 1 or a 0. So the answer for this would be 2 to the power 3 times 1 times 1. So 2 to the power 3, this is the answer for this question. So 1 second. So does anyone have any questions? You want me to repeat any problem that I went over? I don't think Sir went over the axioms of probability for in last class. If he did, then that is included in the syllabus. So the syllabus is technically all of the 4 classes that Sir has had up till now. Have you guys started preparing for the quiz? I don't think sirs cover that much of chapter 2, so it shouldn't be that much of an issue. So just for the quiz, just practice all of the homework that sirs given, and you should be good to go. So it's your first quiz, so it shouldn't be too difficult. So if you don't have any other question, I guess. No, sir doesn't test the proofs because it's technically an LMS quiz. So he usually gives you an option to enter the answer. And I think sir also mentioned this in class. So you'll have an option to either enter the answers, or if you want to upload your working, so you can do that too. If you're not certain whether your answer is correct or not, so it's better if you upload it so you can you can get partial marking for it. Yeah, no problem. Any other questions?
I don't know अगर अभी तक किसने पूछा या नहीं पूछा because I joined a little late. लेकिन assignment में question number 10 था, उसमें B part में I was really confused क्योंकि I know what the सही answer is but I don't know कि गलत answer जो मैंने निकाला था वो सही क्यों नहीं है. तो
गलत आंसर सही क्यों नहीं या गलत क्यों है?
हाँ, basically गलत क्यों. हाँ.
I think someone also posted on Piazza for this कि part B जो था कि how many if she must answer at least 3 of the first 5 questions.
Exactly वही वाला सवाल था.
तो उसमें हाँ I think was it the same mistake? आपने भी method 2 से method 2 में आपको मतलब मुश्किल हो रही होगी as an understand.
Exactly. मेरी भी वही same mistake थी कि I did 5C3 into 7C.
I think 3C5 and then 7C जो भी remaining थे I think 4 yeah. तो it's technically आप इसको इस sense में सोचो ना कि आपके पास first five questions है, उसमें से you're saying let me choose any 3 questions of those, and then after you've chosen 2 of those questions you're saying let's choose it again now. तो that doesn't make sense. इस तरह से तो आप कोई भी probability का सवाल लो, if you say कि मैं पहले choose करूं which of those should I not choose, and then you're saying choose them again, so इस sense में वो गलत है. And
as in, are you saying that I can only choose once?
As in, once you've already chosen to choose something, so then why are you saying there's an option to choose it again then? Like
क्योंकि I was taking into account the probability कि अगर वो 3 से ज़्यादा हो तो फिर भी तो हो सकता है ना, basically वो 7 में ही include हो गए वो बाकी भी.
अच्छा एक second, let me just open this up. इसको मैं तो मेथड 2 में उसको मैंने कमेंट करके दिया था, वो आपने पढ़ा था वो कमेंट?
जी मैंने पढ़ा था लेकिन मुझे समझ नहीं आई.
ठीक है से तो टेक्निकली मेथड 2 जो है वो मैं अभी आपको समझा देता हूँ फिर.
अच्छा वेट, वो जो मेथड जो सही वाला मेथड है जो 5C3 into 5C4 plus
5C3 एंड देन उसको मेथड 2 को मैंने उसको ब्रेक डाउन करके फिर लिखा था कि ये इस सेंस में आप समझ ले कि केस 1 दिस इज केस 1 2 3.
अच्छा ये मुझे समझ आ गया था, दिस मेड सेंस टू मी, लेकिन मुझे ये नहीं समझ आ रही कि वो क्यों गलत है जो मैंने किया.
Just one second. तो इसमें यह है कि अब आप कह रहे हैं कि you have 3 questions in front of you. 3 questions में से choose 3. Sorry, you have 5 questions in front of you. अब 5 questions में से choose any 3. And then after that, in these 2 scenarios, मसला जो है ना इन 2 scenarios में आ रहा है Not in scenario one. In scenario one में there is no double counting. Double counting सिर्फ और सिर्फ हो रही है case 2 and 3 में. In which case 2 is case she chooses four of the first 5 questions, and case 3 is she chooses 5 of the first 5 questions. तो इसमें अब आप ये कह रहे हैं कि 5C3 you choose the first 3 questions out of the first 5 questions आप first 3 को करो, and then आप दोबारा 2C2 कह रहे हैं, and then ऊपर भी यही इशू है कि आप 2C2 दोबारा कर रहे हैं. तो इन दो मिस्टेक्स की वजह से यहाँ डबल काउंटिंग हो रही है कि ये जो चीज जो है इट्स बीइंग रिपीटेड.
अच्छा ठीक है, आई गेट इट, ठीक है, समझ आ रही है.
So any other questions?
नहीं, थैंक यू सो मच.
No problem. Thank you all for attending. I'll end it here now.
Excuse me,
Yeah. जी.
एक क्वेश्चन बुक में से था, उसका डाउट था.
Sure.
It's kind of long. Are you sure you want to keep recording?
एक second. So I think I'll start right now. लोग आ गए. So welcome to your first Math 230 Pro tutorial, and I'm Mushtaba Shah, and I'll be holding a tutorial. So could someone confirm if you can see my screen and the Paint app?
Yes.
Okay, thank you. So we'll start with this question. So I'll read it out. I'll give you guys some time to think about it, and then we'll solve it. So the question problem is that Alice invites 6 guests to her birthday party: Bob, Carl, Diane, Eve, Frank, and George. So Alice says that let's change the seating every half an hour until we get every seating possible. So the problem is asking us how long this is going to last if Alice stays at the head of the table and they'll keep on changing the seating arrangements every half an hour. So does anyone, I'll give you some time to think about it. So does anyone have any guesses? So how would you think we would want to start this question? Like, how would you go about it? You can speak out. I can't exactly see the chat. Yeah, so that's perfectly right. So they're technically, there are technically 7 people, but among those, we've already said that Alice is going to be sitting at the head of the table. So she's at one end, and then you have 6 more seats, which are empty. 3, 3, and sorry, that's 4. So just like you mentioned, it's going to be 6 factorial because we have Alice over here. We have this option, this seat. So for this first seat, we have 6 people that we can seat: Bob, Carl, Diane, Eve, Frank, and George. So we can choose any one person that can sit at the first seat. For the second seat, we have 5, then 4, then 3, all the way to 1. So that gives us 6 factorial, just like you mentioned. That's exactly how many possible ways we can have of seating arrangements. So the question doesn't stop here. The question is specifically asking us, how long is this party going to last? How long is this party going to last? So it's asking us if they change the seat every half an hour. So our answer would be that this is 6 factorial is equal to 740. And they technically change the seats every half an hour, 30. And times 30 because they take 30 minutes per seating arrangements, and then you divide it by 60 times 24. So we get the number of days that this will take, which is 15 days. Does anyone have any questions with this? Do you guys understand it? If not, let me know.
The 720 is the 6 factorial. The 30,
Yeah.
720 into 30 is the half an hour divided by 60 for full hour and multiplied by 60 to 24, that is for the days.
Yeah.
Right?
Yeah. 6 factorial because you have 6 factorial seatings.
So generally, yeah, the seatings is 6 factorial, that's it.
And if we don't have this condition that Alice stays at the head of the table, so then what would be the answer in that case?
7 factorial.
7 factorial, exactly. You're right. So how is that? Because technically we have Alice over here, but now we're saying that we won't necessarily have Alice there. So, and we have a total number of 7 people now. So this starts from 7, the first seat, we can give it to 7 people. The second seat, we can give it to 6 people. The third seat, we can give it to 5 people, all the way up to the last seat. So that's 7 factorial. If we were to, for example, say that Alice can also sit anywhere, which is equal to 5040. So, okay, let me just copy the other question. So now the question is saying that they now decide to play cards instead. So they play a game called Bridges. They play a game called Bridges in which the deck has 52 cards. Each player gets 13. And there's one opponent that says that he's claiming that he has the same hand that he had last time. By hand, I mean the card gets a certain the player gets a certain number of cards, and what card is saying is that he's getting the same number of cards, the same combination of cards that he got in the last period. So what I want is to know the probability of such an event occurring. So, like, what's the definition of probability? Sir told us the number of sample spaces in that particular outcome divided by the total number of sample space. Total number of sample space. So we have, so I'm going to solve this part now first. So we have 52 cards, of which a player gets 13 cards. How many possible combinations could we have of a person getting one hand? You can say it out too. Exactly. 52, choose 3. And so this is pretty obvious that it's 52, choose 3. So what's the probability of it? What would the numerator be in this case? Yes, you're right. The numerator would be 1. So the denominator is 52, choose 3, because we're technically saying the total number of combinations of cards that you could have is this particular amount. Of that, there's only one particular hand in which that card would have won. For example, like we could say he had one ace and one heart and something like that, and there's only one particular combination. So the probability of that would be 1/52, choose 3.
Why is this 3?
13. Yeah.
13.
Yeah. So it's this value. Yeah, it's 13. Next question.
Excuse me.
Yeah.
ये तो होगा अगर if we just consider getting that hand once, but we're considering that Carl got that same hand twice.
नहीं
So
नहीं yeah, आपका बोलो.
so ये square नहीं हो जाएगी ये probability?
नहीं नहीं. That would be the case like if for example someone were playing a cards game and I'm calculating the probability of me getting the same combination of cards twice in a row. But in this question, you have to be careful about the phrasing that they've used, because they've mentioned here that Carl is stating that he has the same hand that he had last time. So one of them is an event that's passed, that has already happened. We're not calculating that because he's saying that whatever number of combination of cards he had that, and now he has the same hand again. So you have to be just a bit careful to make sure you don't misinterpret the question, because it didn't say that we want the probability of getting the same hand twice in a row. It's just asking it, okay, what's the probability if someone makes such a claim? Is that true or not? Does that answer your query?
Okay, so the one is basically that a particular hand which he got the first time, and then that's out of these number of possible options.
Yeah, because this 52 choose 13 is the total number of combinations that you can have of a hand, and of that he's saying that the last one that he had, he can only get one of them. So he's saying that he has had the same one. So we're only calculating the probability of that happening once. Yeah, not twice. If it were like you're saying like the probability of someone getting the same hand twice in a row, so then yeah, you would be right. So that would be technically what you just mentioned.
Could you just explain the difference between the two again?
In one, you're saying that getting, just 1 second.
Okay, so I think I got it. So it's like when you specify that, okay, what's the probability of getting this particular hand 2 times in a row, then you have to square it. Whereas when you just say that, okay, you got some hand in the first try, and now what's the probability that you get the same hand again?
Yeah, exactly.
Okay, so I got the difference. Thank you.
Yeah, so that's different. So you just need to be a bit careful about the wording that it's mentioning. So I'm copying the second question. Can you see the new question? Could someone confirm, can you see this question?
Yes, we can see it.
Okay, thank you. So now the sixth guest decide that they want to play chess. Alice is out of the equation. She's just the one setting up the boards. So the question is asking us, how many ways can the guests be matched with each other given these two conditions? It should not count as a different pairing if two people at the same board switch places. So like if I say that I'm Mujtaba and I'm playing a game with someone called Asim. So Mujtaba versus Asim and Asim versus Mujtaba is essentially the same thing. It doesn't matter if I'm sitting at position 1 or if I'm sitting at position 2. So this is what the first one is saying. And the second one is saying that if you have a set of 3 or 4 or how many ever like chessboards that you have, it doesn't matter whether I'm sitting at the first chessboard towards the first chessboard, or if I'm sitting at the second chessboard, or if I'm sitting at the third chessboard. So essentially, this question as a whole, it's like you could think of it in the sense that they're more of looking at the combinations and not of arrangement as such. So if you want to proceed with the same one, the easier way would just to incorporate these things later onwards. Like you can incorporate them just by the method that's mentioned here via repetitions and inclusion in a denominator. And first we can make up the permutations of the total number of ways that this could occur, which if it's 6 chess boards, 6 players, so that's 6 factorial because you have 6 places. 6, 5, 4, 3, 2, 1. But you also have to account for these two things. So would someone want to clarify, would someone want to guess as to how we take into account the first condition? So iska technically ye hai ki like if you have two people sitting here, it's saying ki if this person gets up and sits here and this person gets up and sits here, it's the same thing. So इसमें यानी हम to account for this we will divide it by 2 factorial because repetition जो है वो उस sense की है. But we don't just stop at 2 factorial. We have three sets of people who are playing chess against each other. So it's these two people. These two people can also switch their positions. So it's 2 factorial there. And then there's another one here too. And you do the same thing for them because if they change places, so it's essentially the same thing. And now it's also saying it doesn't matter like if there's one board here, one board here, one board here. If this person gets up and if this group gets up and they sit here, it doesn't make a difference. And if this group comes, and sits here, it doesn't make a difference. What matters is with the combination of people that are sitting there. So any idea, any guesses how we would incorporate this? So we would do this because there are 3 blocks of people that can get up, 3 blocks of people playing chess that can get up and sit somewhere other place. So we would incorporate that by dividing it by 3 factorial because that's the total number of repetitions. And we also have this thing. So we divide it by 2 factorial, 2 factorial, and 2 factorial. I think someone had a question. Why aren't we doing 6C2? Because that would be choosing the first 2 people, only the first 2 people for for one board. Okay. So does anyone have any questions? Yeah, should I go on to the other part? ठीक है, तो I'll start a new one. The other question. ठीक है. This question is actually the same question that sir has done with you in class, but I want you to go through it in another method. So technically, it says that we want to pick a committee of two women and 3 men from a total of 5 women and 7 men. And there are 2 specific men that refuse to be on the committee together. So sir went through this by defining cases. Like one case was that you have neither of the futures together. The other case was that you have one of the futures together. So in both of these scenarios, we weren't having both of the futures together. So it was fulfilling it. But there's another way to go about it. Like essentially, we could first find out the total number of ways that we can make the combinations, the set of combinations through which without any restrictions, which is 5C2 times 7C3. अब इसमें से this includes case 1. Both of the 2 men who are fighting are together. Case 2, you have neither of them. Neither of them. And here the third one we have is at least one of them. So this total that we've calculated above is actually a culmination of all of these 3 cases. So if we don't want to go through the hassle of calculating neither of them, case 1 and case 2, we can just calculate sorry, 1 second. Calculate them calculate them being together and subtract that from the total number that we have above. So the total number that we have together is 2C2, where you're selecting the 2 people that are feuding, that are together, and now we select the woman 5C2. That doesn't change, and now we've already selected 2 men out of 3. So there's only 1 man that's supposed to be selected, and we only have how many remaining men? We only have 5 remaining men. So that's 5 choose 2. 5 choose 1. Sorry. Because we had to choose 3, and we've already chosen 2 out of the 2 feuding men here. So this gives us the total number of ways, total number of combinations that we can have of these 2 people together, which is equal to 50. This thing is equal to 350. So if you subtract total minus together, you get at least one of them, which is equal to 350 minus 50.
I think it's not at least, it's at most 1.
Yeah, sorry, at most 1. So you get that कि वो 300 हो जाते because एक के ये cases को हमने divide किया था, total is this thing, so हमने neither हमने उसको उस चीज से minus किया, and then we get the cumulative answer. Any questions? ठीक है से तो I'll go on to the other question. ठीक से अब this problem is also another permutations वाला problem. It's saying that we have a set of 3 boys and 3 girls. अब how many ways can you sit them in a row? Since we haven't distinguished between boys and girls, so it's going to be 6 factorial. पहले boy बैठाओ पहले girl बैठाओ तो it doesn't make a difference, या किसी को भी जिस तरह से बैठाना वो मसला नहीं है. Then अब दूसरे वाले में they're saying कि if the 3 boys and the 3 girls are each to sit together, मतलब all of the 3 boys are together, then all of the 3 girls are together. अब इसको आपने एक ब्लॉक बना दिया, इसको आपने एक ब्लॉक बना दिया. Within this we say for example यहाँ boys यहाँ बैठे हुए, ये girls यहाँ बैठे हुए, and you have 3 factorial ways of arranging these people, 3 factorial ways of arranging these people. But then you could also have girls first and boys second, so then you multiply that by 2 to get the final answer. इसका ये बनता है जो भी अमाउंट बनती है. Now if it says कि if only the boys must sit together, तो अब हम इसको इस सेंस में करें कि 3 का हमने एक ब्लॉक बनाया जिसकी हमें permutations calculate की, and then we have to the remaining 3 girls. इसको once we've calculated the total number of ways that we can calculate of the boys sitting together, and then after that we have 3 remaining girls जिनको हम किसी भी जगह बैठा सकते, either at this end or over here, and इनकी हम permutations कर सकते, and this block of the boys can also go towards the right side. तो अब इनकी फिर बनती है 1 2 3 4 factorial ways of arranging these people. So the answer is 4 factorial times 3 factorial. तो इसका ये हो गया. Any questions? किसी को कोई बात मैं दोबारा समझा दूं? ओके, थैंक यू. तो ये वाला सवाल देता हूँ, आप लोग ट्राई कर लो सॉल्व करना. So the question says that 20 workers are to be assigned 20 different jobs, one to each job. How many different assignments are possible? कोई if any one of you wants to answer तो भले unmute करके वो बता दे कि किस तरह सॉल्व करेंगे, या चैट में लिख लो. ट्वेंटी P20 ये कैसे? ठीक है से it is actually 20 factorial 2 here because 20 different jobs. तो आप इस तरह से सोच ले कि भाई एक बंदे को कितनी जॉब, एक जॉब जो है वो कितने लोगों किस बंदे को जा सकती है. It could go to person 1, person 2, person 3, all up to person 20, and then you have the second person, you have the second job. Then that once you've given one job to one person, so then you have another job to give out to the remaining people. तो 19 हो गई. तो अब उस तरह से फिर 20 factorial all the way goes up all the way to 20 times 19 times 18 dot times 1. या मानो आप बोल.
Isn't 20p20 correct?
20p20 किस लॉजिक के साथ आपने किया?
Basically 20 boxes हैं जिसमें 20 लोगों को fit करना है, तो basically इस तरह नहीं हो सकता.
हाँ,
और
actually you're right, 20p20 is the same as 20 factorial.
ठीक है.
It's essentially the same thing.
Thank you.
Yeah, no problem. ठीक है. Problem 9 so says that we have 5 separate awards: best scholarship, best leaderships, and so on, and they're to be presented to selected students from a class of 30. How many different outcomes are possible if a student can receive any number of awards? तो इसका फिर क्या कहेंगे आप लोग, क्या आंसर होगा? Yes, 30 to the power 5, because you have one student can get 30 awards, and onwards, so one award can go to any one of the 30 students, and then one student can also get more than one awards. So then you have another 30, 2, 3, 4, 5. ठीक है? So first award can go to any one of the 30 students, second award can also go to any one of the 30 students, and so on until the 5th award. So that's why it's 30 to the power 5. A B part is saying that if each student can receive at most one award, either he receives an award and he can't get any other award. For example, if he has best scholarship, he can't also be the best in terms of leadership qualities. So how do you think we should go about in this case? Yes.
अच्छा, ये पिछले वाले में 30 to the power 5 क्यों आया?
30 to the power 5 इस सेंस में है ना कि अगर आपके पास एक अवार्ड है बेस्ट स्कॉलरशिप एंड आई हैव 30 स्टूडेंट्स, तो how many ways can I distribute that one particular award? 30 and then I have another award, कोई बेस्ट लीडरशिप का हो गया है, तो वही इसी सेंस से फिर आप यही सारे जो 5 अवार्ड्स जो है उनको आप डिस्ट्रीब्यूट कर सकते हो. अब the second question is saying that if one student, for example, he's a valedictorian of a university or something, so he can only get one award. He can only be best scholarship, best leadership, or best grades or something like that. So in that case, what happens is if you look from a awards perspective, so if you have one award, that the first award that can go to any of the 30 students, but once that one award is already allotted to one student, that only leaves how many? 29 students to be awarded the second award. And then when you go on to the third award, the same logic applies. You get 28 students all the way till 26. 1, 2, 3, 4, 5. हाँ से. So इसका फिर इसी लॉजिक से है कि ये first award can go to any of the 30 students. Then there's one student that's received one award, so he's out of the equation. Then there's another student who can receive 20 there's another award, और उसमें से सिर्फ 29 students बचते, तो so he can only, there are only 29 other students that can receive that particular award all the way up to the 5th award जो ये है. Yeah, 30 P5, you're right. ठीक है. Yeah, Mohammed, I will also be uploading the tutorial. No problem. अच्छा, this meeting is about to end, तो मैं इसी लिंक को रीस्टार्ट करके and then this is my last question, तो मैं इसको बस go through कर लूँगा से, तो it's about to end any minute, तो उसको बस rejoin कर देना please. Thank you.